Algebra 2, this is Triangle Trig, Week 2, Part 2, solving a triangle. Okay. So in this last part we did, in Part 1, we set up a trig function and solved it for a side. We set up a trig function and solved it for an angle. And now we're going to do both of them together to do what's called solving a triangle. Okay. Solving a triangle means to find all the sides and all the angle measurements. So find all sides and angle measurements. Now obviously you can't do that for just a blank triangle. Some things have to be given to you. Now different things are going to be given to you. Sometimes it always has to be a right triangle, so you're going to have the 90-degree angle. And then sometimes you'll be given two sides and an angle. You might be given one side and an angle. We're going to do a couple different scenarios. You might be given two angles, no side. But we'll run through a couple of those. Alright, so what you can do is if you're missing, say you're missing an angle or you're missing a side, you can set up a trig ratio to find all the missing information. We know how to set up a trig ratio to find a missing side. We know how to set up a trig ratio to find a missing angle. So you can do that for all of your missing parts. But there are some other techniques, some kind of shortcuts that we could use that don't involve trig. Well, not the trig ratios, at least. So the first thing that we could do is we could recall from geometry that all angles in a triangle add up to 180 degrees. So for example, if you know two angles in the triangle, you automatically know the third one because they have to all add up to 180. And since these are all right triangles, you could also use the Pythagorean Theorem to find a missing side. Remember that theorem states that a squared plus b squared equals c squared. Okay. And c squared has to be the hypotenuse. Alright, so the 180 rule helps a lot. The Pythagorean Theorem, it's still a lot of steps in Pythagorean Theorem. Some people just prefer to do trig ratios. I'll do a couple of each. Alright, so on this triangle, this first example, let's see what we're given. Okay, we're given, obviously, the right angle. That's always going to be given because it has to be a right triangle. We're given this side of 15, and we're given this angle of 72. Now, one thing I always want to do is I want to label what we don't know. Okay. These side lengths aren't labeled. Usually how we label sides in a triangle is whatever angle is across from it is that side length. So across from angle A is going to be side A. And sides we use lowercase letters. Angles we use uppercase letters. Okay. So across from angle C is going to be side C. And then this would be side B, but we already know it. Alright, so we know angle B, or we know side B. We don't know side C, and we don't know side A. So we have to find those. And we know angle C is 90, we know angle A is 72, but we don't know angle B. So the first thing we're going to find is angle B. And again, we're going to use the rule that says that all sides of a triangle, or all angles of a triangle, add up to 180. So that means B, angle B, which we don't know, angle B has to be 180 degrees minus angle A, which is 72, and minus angle C, which is 90. So the measure of angle B is 18 degrees. Alright, so we already found one of the parts. Let's find, so now we're only missing side A and side C. Let's find side A next. Okay. Now side A, you're going to have to set up a trig ratio for. Okay, you can't use Pythagorean Theorem because we only know one side. You have to know two sides to use that. So we're going to have to set up a trig ratio. So again, setting up a trig ratio, you have to use the angle that you know. Okay. So I always use the angle that I'm given. So we found that angle B is 18, but you might have made a mistake finding that angle. So you always want to use something that's given. Okay. So we're going to use angle A. Side A is opposite of angle A. And then the only other side that we know is adjacent to angle A. And we don't know the hypotenuse, so we can't use it. All right. So we have to decide what trig function uses opposite and adjacent. Okay. So it's always good to write these down. Okay. Sine and cosine both use the hypotenuse, so it can't be those. So it's got to be tangent, which is opposite over adjacent. Okay. So our trig function for this is going to be the tangent of the angle, which was 72, is equal to the opposite side divided by the adjacent side, which is A over 15. Okay. And then solve for A. Remember that if your variable is in the top of the fraction of the ratio, you would just multiply both sides by 15. Okay. So side A is going to equal whatever 15 times tangent of 72 is. Okay. That's going to equal A, and in this case, A equals 46.2. Okay. Alright, so we just found angle A. Now the only thing that's missing from this triangle, from knowing all three sides and knowing all three angles, is side C. We don't know the hypotenuse. So you have a couple options here. You could use one of the trig functions. Sine and cosine both use the hypotenuse, and we know the sides. You could also use Pythagorean Theorem. So on this one I'll use Pythagorean Theorem. We know side A, we just found it. We know side B is given to us. And we're trying to find side C. So you could plug it into Pythagorean Theorem. A squared, which we just found was 46.2, plus B squared, which is given to us at 15, equals C squared. So you could just punch that into the calculator, do 46.2 squared plus 15 squared, and you get 2,359.44, and that equals C squared. Now what a lot of people are forgetting, they're forgetting to do the square root of that. We don't care about C squared, we only care about C. So you're going to have to take the square root of that, of both sides, and you get a C value of 48.6, which is the last missing side. Okay. Now again, you could have used a trig ratio for that. You could have said, for example, the sine of 72 equals opposite over hypotenuse, which would have been 46.2 over C, or you could use cosine. So actually I'm going to do, so the alternate for that, for finding C, is we could have done cosine of 72 degrees. Well, the cosine of 72 has to be adjacent over hypotenuse. The adjacent side was 15, and we don't know the hypotenuse. Okay. Remember, if you have variable in denominator, you just switch these two positions. So side C should equal 15 divided by cosine of 72. And you get the same thing. You get 48 point, it's a little off, a little rounding error, but 48.5. So you get the same answer, just a different method. So it's up to you if you want to do trig ratios, or if you want to, find two sides and use Pythagorean Theorem. Doesn't matter. All right, but that's solving a triangle. We found all the side measures. We were missing two sides, and we found them, A and C, and we were missing one angle, and we found that, angle B. Okay, in the second example, we're given two sides and the right angle and nothing else. Okay. So the first thing I'll do on this is label what we know. Okay. We know side F, lowercase f, across from angle F. We know side D, lowercase d, across from angle D. We don't know side E, which is the hypotenuse. It's across from the right angle. And we don't know angle D, and we don't know angle F. Alright, so we're going to find those angles using trig ratios. Now the hypotenuse we could find right away. Because, again, we could use just Pythagorean Theorem. Okay. In this case, instead of a squared plus b squared equals c squared, since our triangle is not a, b, and c, it's d, e, and f, really we have d squared plus f squared equals e squared. Again, the variables don't matter as long as what it equals is the hypotenuse. So e is the hypotenuse, so it has to equal e squared. Usually c is the hypotenuse, so it equals c squared. So we could solve this right away. 22.5 squared plus 21 squared equals e squared. Punch that all into the calculator and get 947.25 squared equals e squared. And then square root both sides. And you get an e value, or side e is going to be 30.8. Alright, so that side's out of the way. So now the only thing we're missing is the angle measures. We're missing angle D and angle F. So just pick one to start. Let's start with angle D. Angle D, you want to label the sides now with respect to angle D. Across from angle D is going to be the opposite side. Okay. We already have the hypotenuse labeled, which means side F is going to be adjacent to angle D. Now again, you don't want to use the calculation that we found. We found that side E is 30.8, but 30.8 is rounded. Okay, it's actually 30.777. So you want to use the given information just in case you made a mistake in one of your other calculations. You won't miss the entire problem. So if we want to find angle D, we have to somehow find a trig ratio that uses the opposite and the adjacent sides. Now again, that's going to be tangent. Okay. So what that means is that the tangent of angle D is going to be equal to the opposite divided by the adjacent sides. So 22.5 opposite divided by adjacent 21. Again, remember when you're solving for an angle, you can't just divide by tangent. You're trying to get D by itself. So you have to take the inverse of both sides. So angle D is going to be tan inverse, or second tan on a calculator, of 22.5 over 21. So angle D equals 47 degrees. Now again, you could set up a similar trig ratio to find angle F. Or you could use the fact that all these angles have to add up to 180. So to find angle F, I'm just going to do 180 minus the right angle minus the angle we just found, 47. So for angle F, you're going to get a measurement of 180 minus 90 minus 47 is 43 degrees. Alright, and that is, now we know every angle and we know every side, so we've solved this triangle. Now again, from both of these, we only had to do one trig part. Okay, you could, if you opt to use the 180 degrees and the Pythagorean theorem, you really only have to set up one trig ratio. Now again, you can set up three. You could use trig ratios to find all the missing information. but you don't have to. Usually you only need one. So use whatever method you want. If you want to use all trig, use all trig. If you want to use these other methods, use these other methods. Whatever works for you. And that's solving triangles. Have a great day.